Woohoo, welcome back. Today we're going to be working with practice with the greatest common factor technique of factoring polynomials. So in this technique, we're going to be looking to see what the terms have in common, which is going to involve times tables, and possibly, if your times tables are a little bit rusty, definitely have a calculator on hand. So let's go ahead and get started. Woohoo! Number 1, 56x minus 21. First thing you want to do is think about whether they have anything in common. If you're anything like me, you're looking at those two numbers going, I don't know if they have anything in common. So I'm going to break each one down. I happen to know that 56x, let me rewrite it. 56 is actually 7 times 8. And 21, wait a minute, is 7 times 3. And if you have two terms that have something in common, in this case, the 7, you use the distributive property and we run it backwards. And we say, okay, if there's 7 in both spots, then we can pull that 7 out and then write what's left. So if this were 7 times 8x, we just write the 8x part, the part that's left over, and then the minus, because there's the minus in the middle. And then this is 7 times 3. We're going to pull out the 7, and we're going to get the 3. And so this is like running the distributive property backwards, because if we were starting here, we would do 7 times 8x. That would give us this term. And 7 times negative 3, which would give us this term. So this is what factoring is. It's running the multiplication backwards. And it is very much related to division. It's just a slightly different way to look at it. Okay, in the category of that escalated quickly, suddenly we go from this to, oh my goodness, right? So I'm going to go ahead and write it out, make sure I understand it. It's 4x squared y z to the 4th minus 8x z to the 4th plus 12x squared z to the 4th. And what I need to do is figure out who's common. And again, you can do this in your head, or you can write this out, whichever works the best for you. So for example, you might look and say, oh, 4, 8, and 12, there are 4s in common. Or you may want to go ahead and just write the whole thing out. It's going to take a little bit. 3, 4, minus 8 is 4 times 2, x, z, 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 z. And then 12 is 4 times 3, x, x, and then z, 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 z. Okay, so now either from this step or from this step, you want to find the things that are common between the three terms. So for example, I see a 4 in each term. Then I look at the x's, and I definitely see some x's, but there are a different number of x's, and you try to take the most x's. So there are 2 x's here, there's 1 x there, there's 2 x's here. I'd love to take 2, but this one doesn't have 2. So I try to take the most that they all have, but this one at most only has 1. So I can only take the one that they all have in common, sadly. Okay, now with the z's, in this form, it's a little bit easier to see. Z to the 4th, z to the 4th, z to the 4th. If they all have the same number of z's, they're all z to the 4th, we can factor all of them, all 4 out from all 3 terms. So let's go ahead and combine, see what we've got. I'm going to pull out the 4. I'm going to pull out 1x, and I'm going to pull out the z to the 4th. So in a full color situation, I've got the 4, which was blue, the x, which was yellow, and the z to the 4th, which was red. And for those of you for whom color is not what you're looking for, I'm going to go ahead and put a dot here, a dot under each of the 4s. There's that 4 with the dot under it. I'm going to leave the yellow unmarked. And for the red, I'm going to draw a second line underneath so that they're easy to distinguish, if that helped at all. So I'm going to pull out what's common, and then I have to write down what was left. So let's look. I took out the 4 and the x and the 4 z's. That leaves this x and this y. So I've got just the xy in that first term. In the second term, I took the 4 and the x and the 4 z's, so all I have left is that 2. And see how this is a minus there? So we got to have a minus 2 in this one. And then for the last one, I've got a plus. And then let's see, I think I've got a 3 here and an x. And that's our answer. 4x z to the 4th times xy times the quantity xy minus 2 plus 3x. I'm going to go ahead and rewrite it without the colors attached, so I can put a box around it more easily. That's your answer. And when folks ask, do I have to go to all this trouble? And the answer is no. If you can see it in this format, use this format instead. Okay, oh my goodness, that got very colorful very quickly, didn't it? Now let's look at this last problem. 12x squared minus 36x plus 27. Now this is a case where we do have a trinomial, so we probably are going to have to go further than just the greatest common factor, but we should always start with the greatest common factor because it'll make the numbers smaller if we're able to do it. So the question I have for you is, what do 12, 36, and 27 all have in common? And if you think about it, you can think about, okay, 12, that's the smallest of the numbers, so let's look at that one. That's 3 times 4. 3 goes into 12, 4 goes into 12, 3 goes into 36, so does 4, but the only thing that goes into 27 are the 3's. So the thing they have in common is 3. So I'm going to factor out a 3, and that's going to leave me with, and here we're thinking division, 12 divided by 3 is 4. Negative 36 divided by 3 is negative 12. And 27 divided by 3 is 9. Because the last term doesn't have any x's, I can't factor out any x's. There are no x's in common. Okay, so now we've got a situation where we've got a trinomial, and you've got multiple methods for factoring. Let me pull that initial page out. For factoring a trinomial, 1, 2, 3, you have 3 terms. We've got trial and error, or the AC method, or the X method. So 3 methods, or we might get lucky and maybe it's a perfect square. And that's where I'd like to focus right now. Let's see if this might be a perfect square. So, I don't know if we can get this, all of this into the, there we go, kind of okay. So a perfect square looks like this. It has a squared. Now this has a minus in the middle, so I'm going to be looking down here. Minus 2ab plus b squared. And if we have that, then we have a minus b. Oops, gotta scooch this over a little bit. A minus b, the quantity squared. So if we do have this pattern, now we don't know if that's this pattern. So what I'm going to try to do is I'm going to try to match this pattern to this pattern, and then we're done. We don't have to do any of the other fancier ways to factor. So I'm going to give myself some brackets, which is always what I do when I'm going to start getting lots and lots of parentheses. So 4x squared, the first term needs to be something squared. So can we write the first term as something squared? And the answer is yeah, we can. That would be 2x, the quantity squared. Okay, and then in this formula, the last term has to be something squared. So the question then is, do we have, at the end, is the 9 something squared? So here's the 4x squared. Here would be the 9. And yeah, 9 is 3 squared. Okay, this is looking good so far. The first term is a perfect square. The last term is a perfect square. Now what we need in the middle is we need a minus 2 right? And an A. And we need a B. This is how you build a perfect square. So you need a plus or minus 2, depending on what you've got, and then one of the A's and one of the B's. So let's check. Negative 2 times 2x times 3. Negative 2 times 2x is negative 4x times 3. Oh my goodness. 12x. We got negative 12x. It's going to work. This is a perfect square. Woohoo! Now, could you use the AC method or trial and error or another method? Absolutely. And for those of you who've gone further, could you use the quadratic formula if you know how to use that? Absolutely. This is just another tool. It's another pattern that if you happen to recognize it, awesome. It makes the problem easier. Okay, so since I have, let me write this out, it's a perfect square. Woohoo! Since it's a perfect square, I can use this formula and I say, okay, I've got the 3 that was outside. Then I take the A, which was the 2x, minus the B, that's the 3, and write it as squared. And that's it. We've got our completely squared, or sorry, completely factored trinomial. Woohoo! Okay, you guys are awesome and amazing. And, go get some hydration, go get a snack, and then I'll meet you back here for more factoring videos. Woohoo! Yay, math on.